take part by asking questions. And you can do this at any time throughout the meeting by typing your question into the chat on the menu bar. And I will ask these questions at the end of the presentation on your behalf. Or if it's easier for you to ask your question verbally rather than to type it into chat, can you please use the raise your hand function on the toolbar at the top of the screen? And then I'll come and ask you what your question is, but remember to unmute yourself when you ask the question. Alrighty, so I think that's enough of an introduction, and I'll hand over to Emily. Thank you, Emily.
Thank you, Phil. Welcome, everybody. I go straight into the subject. So last webinar, about a month ago, we talked about the problem weeds in kine and the importance of having a good knowledge of the target weeds, their distribution, seed spread, the factors that influence their germination. We also focused on the economic impact of weed competition and also the phytotoxicity impact of herbicide on kine and what type of economic value that meant. We also talked about plant back issues when using persistent herbicides. So today, we're going to focus more on weed management options, current knowledge in terms and techniques used for managing weeds. Most of the presentation today is related to chemical control, as it's our main mode of controlling weeds. And I'm gonna also talk about some non-chemical control options that we could consider in the future. We'll follow this presentation by a quick online poll that Phil's gonna run to you, and a quick survey to determine what your next favorite webinar topic in the space of weed management would be, and some time for question and answers. So straight into the subject, weed management. Nowadays, we're not really talking about weed management, but about integrated weed management, which is a more proactive approach to control weeds through a long-term management approach that would use a combination of weed management techniques, not only chemical control. So chemical control is the use of herbicide in a broadcast, directed, zonal, or spot spray method, but integrated weed management also take into account other methods to control weeds, like physical control, biological control, or cultural control. Physical control means mechanically removing the weeds or removing mechanically the weed seeds. Mechanical is a general term that can also include electrical removal, steam removal, or flame removal. Biological control is using biological agents in general for weeds. We're talking about fungus or insects to target specific weed pests. Cultural control is basically using advantages inherent to the sugarcane farming system. For example, the fact that we have green cane trash blanket, the fact that our cane varieties compete highly with the weeds, the fact that we can use fallow crops to break the weed cycle, this sort of things. So weed management decisions, and especially integrated weed management decisions, are complex, as we need to understand a range of factors like the crop and the weed interaction, the weed ecology, the weed economic impact, and understand what are the available control method strategy at hand and their impact on the crops and the environment. So basically, the best tool to develop integrated weed management recommendation is a human brain, which is why there's weed agronomists, crop consultants, and growers that have built their integrated weed management skills over the years by a range of training workshops and mainly hands-on experience. Nowadays, we're moving into more and more computer modeling, and in the near future, I wouldn't be surprised if we'll see computer simulation modeling play a role in making this integrated weed management decision. The concept of integrated weed management modeling has been explained by a few authors. Some Australian authors, Renton and Chauhan in the grain industry, have developed the concept that how an integrated weed management model would work so it would work by integrating a weed population dynamic model, so some existing around the place. The weed seed wizard's been developed in the grain industry in Australia, and can handle a good can handle the dynamic of the weed population. And if we combine this type of model to crop simulation model like APSIM, which are commonly known around the agriculture industry, we can actually better understand and investigate the impact on the weed population of different factors like crop planting density, crop row spacing, row orientation, the weed density, the spatial patterns when spraying or cultivating, the spread of seeds by machinery, the soil environmental condition, and some things like the emergence time of the crop and weed. So it's on the horizon. We're going to be soon replaced by computers that can make maybe better management decision than people. So the next few slides are going to talk about the main tool we use in the integrated weed management, which is the chemical management. The chemical management is basically using herbicides to control weeds. It's the most popular method because it's the most cost effective. It's very suitable for no or minimum tillage farming system, and it's suitable in most adverse soil conditions. It's also the most research area in this space of weed management. Not saying that there's still gaps of knowledge, and as new molecules are released, there's still a lot of work to be done to assess the efficacy of these newly released herbicides on many soil types, different climatic zones, different weed species, the impact on sugarcane varieties. As part of the registration process, a lot of this work is done, but it's not thorough enough to have a full understanding of these new molecules when they get registered. Unfortunately, there's a few drawbacks that comes with chemical management. It requires a fair bit of technical knowledge and a few certification for the user before using chemicals. It requires the use of personal protective equipment because these products are very often more or less harmful for the user, but also for the environment, neighboring crops, succeeding crops, etc. And unfortunately, overusing chemical has led to a lot of weed-resistant issues. So this next slide is about the different type of herbicides. It's a very general slide. I'm not going into much details because I don't have time today. But basically, we can split the different type of herbicides into two categories: the pre-emergent or residual herbicides, which are soil applied. These herbicides are taken up by various parts of the germinating seedlings as they emerge through the soil. They have long-lasting activity in the soil. They can be either selective, which means that the sugarcane has the ability to metabolize them, and therefore they do not harm the cane crop. For example, metribuzin, atrazine, metolachlor falls into that category. Or they can be non-selective, which means the cane cannot metabolize them. And in that case, placement is key to achieve spatial separation between a band of these non-selective herbicides that would sit in the topsoil where the weed seeds are, while the cane roots grow further down the profile. Imazapic and isoxaflutol falls into this category. The second big category of Herbicides are the post-emergent herbicides, which are foliar applied. They can be either systemic, which means they translocate to other parts of the weeds. And for that, an active weed growth is necessary for maximum translocation within the weed. Some are selective, which means they do not harm the cane, which can metabolize them. Some of them achieve mainly broadleaf control, like 2,4-D, fluroxypyr, dicamba. Some achieve grass control, like azulam, while still being quite selective to sugarcane. Or they can be non-selective, which means that weeds and canes do not have any metabolic pathway to break down the chemical. And in that case, we're talking about glyphosate, glufosinate. And if we want to apply them in crop, we have to use methods or techniques so the cane does not get touched, like shields, hoods. Another type of foliar applied post-emergent herbicide are the contact herbicides. These ones act so quickly in the cells of the plant that they do not have time to translocate. Paraquat and diquat fit in that category. For this herbicide, the coverage of the foliage is very important. Otherwise, the poor coverage results in just localized burn-off of foliage without completely killing the weeds. And also this contact herbicide, because they do not translocate well, tends to work better on smaller weeds and are not really good on established perennial weeds. All these herbicides, especially contact and systemic herbicide, can benefit from using suitable adjuvants, and in all cases, the label will indicate which adjuvant suits the compound the best. There's also some pre-emergent herbicides that have post-emergent features. For example, the metribuzin, the atrazine, the ametrine, and the diron, they're both pre and post-emergent, so they can be soil applied, but if there's some weeds around, they would also act through the leaf. A lot of information can be found in the SI weed management in sugarcane manual. It's currently being updated, so look out for the new version in the coming months. Chemical management, there are some performance key points to take into account when we talk about herbicides. The next 4 slides talk about this herbicide performance key point. The first one is timing. Timing is crucial to get your herbicide to work properly. The weather, the weed crop stage, and the weed crop condition need to be taken into account. So for pre-emergent herbicide, in terms of timing your weather properly, ideally you want to apply before a rainfall event that will help to incorporate this pre-emergent herbicide. But you don't want that rainfall event to create runoff, so a small rainfall event or irrigation. Pre-emergent herbicide need to be applied by while taking into account the crop stage, and the label specify what to do in that space. Post-emergent herbicide timing is very important too, and pick a weather that would minimize volatilization of the compound. There's some rain fastness, which means how long the herbicide would take to get into the plant and remain on the leaf is important. The label will also refer to that. So some herbicide need to have, for example, 6 hours without rainfall, so do not apply when an imminent shower is expected. Drift is also something to take into consideration when spraying post-emergent herbicide, so it remains on the target. Crop stage as well need to be taken into account to reduce phytotoxicity on the crop. Sometimes directed spray is the best way to deal with that. Weed stage is important. The label will indicate what weed stage and what rate to use for each herbicide. As a general rule, small weeds are easier to kill with lower rates than larger ones. And weed condition is important for post-emergent herbicides, so you don't want to do it when the weeds are stressed from heat, from moisture, too much or not enough. You want them actively growing to facilitate translocation, especially for these systemic herbicides. And the use of adjuvant can help following the label. The next key point in terms of herbicide performance is more related to pre-emergent herbicides. So pre-emergent herbicides are sensitive to soil type, especially the soil texture, the amount of clay or sand present in the soil, and also the soil organic matter, as both clay and organic matter have an effect on the binding ability of the herbicide to adsorb to the soil particle. As a general rule, heavier clay soil or soil with high organic matter have more binding sites, which means that less herbicide is available in the soil water, and often high application rates are recommended. On the opposite, on light soil, sandy or low with low organic matter, lower CEC, more herbicide is available in the soil water, which means often lower application rates are recommended, especially for those herbicides that are particularly phytotoxic on the cane, like imazapyk or isoxaflutol. The degree of binding also depends on the herbicide inherent properties, such as its solubility or its soil water adsorption coefficient. For example, pendimethalin and trifluralin have got a high KOC, which is the soil water adsorption coefficient, which means they naturally bind tightly to the soil, while herbicides with low KOC, like metribuzin and carbazone or hexazinone, are not binding tightly, which means they're more freely available in the soil water. Another key point to take into account with pre-emergent and also with some post-emergence is the fact that some herbicides are not UV stable, so they degrade in presence of UV light. For example, particularly susceptible to UV light, you've got the S-metolachlor, atrazine, terbutalazine, etc. Some herbicides can be more susceptible to volatilization, like trifluralin, S-metolachlor, pendimethalin are more volatile. They're not very volatile, but more volatile than others. Something else to take into account is a trash blanket is, of course, very rich in organic carbon and organic matter, and also has that particularity that it can bind herbicides. So again, the herbicide that have a high KOC, so which are naturally bind a lot to organic matter, would not be recommended to spray on top of the trash blanket, as they're likely to get stuck to it and not move down towards the soil. Especially pendimethalin and trifluralin fall in that category, to a less extent flumioxazin. How to deal with all these phenomena of photodegradation, volatilization, and trash blanket binding is to incorporate the herbicide. The incorporation can be done with water, like irrigation or rain, and the amount of water that needs to be applied to achieve proper incorporation is a bit variable depending on the soil type, but also depending on the herbicide property. Got a fire alarm here going on. It's lovely. Excuse me. Okay, false alert. Sorry. So basically, the herbicide with low solubility, like trifluralin or pendimethalin or flumioxazin, as I told before, would require higher rainfall, like 20 to 50 mil irrigation or rainfall to be incorporated properly. And ideally, they need moist soil during the weed control period to remain active in that soil water. On the opposite, highly soluble herbicide like metribuzin, hexazinone, imazapyk are very easy to incorporate. and they move freely in the soil moisture. So 5 to 10 mil irrigation is often enough to incorporate them properly. If it doesn't rain, if you don't have access to irrigation, mechanical incorporation is another way to do it. And it can be advised on the label what type of incorporation by cultivation is required. Furrow irrigation, I forgot to talk about it, is normally not recommended for many reasons. The fact that the soil is not wet evenly from the start to the finish of the furrow. So it's too much water on one side, not enough on the other side. And the problem is the herbicide located on top of the row is only incorporated by capillary action from below, and often result in an inadequate level of herbicide incorporation within the row. Another herbicide performance key point is burning the trash. What does it mean? Well, the trick is to aim for a hot burn, because when the trash is converted to ash, which happens when you do a hot burn, the ash actually do not bind herbicide tightly. So it's more available into the soil. On the opposite, if the trash has been burned as a cool burn, there's a lot of charcoal left, and the charcoal bind tightly the herbicide. So it's better to have a hot burn. As well, hot burn maximize the mortality of the weed seeds, which are also killed during the hot burn. So it's better to aim for a hot burn. Soil conditioners, what happened with them? So when I talk soil conditioner, I'm mainly talking about organic amendment or meal byproduct, which have a lot of organic matter. As expected, they bind tightly the herbicides, depending on the type of herbicide we're talking about. And in the current SRA project, which I haven't published yet, I've seen a lot of herbicide efficacy reduction with the pre-emergent herbicide when they're applied on meal byproduct, like meal mud ash, up to 54% when it's applied as a band on top of the return cane, and 44% when it's incorporated in the soil in plant cane. So again, it's because of the high amount of organic matter. So now I'm going to move on to the application technology. So commonly what's used around the place: boom spray, directed spray as octopus leg, droppers, shields. High-rise sprayers are used for, especially for controlling vines. Aerial with plane in helicopters is achieved as well to control vines. So that's what's mainly around the place. What are the latest technology around the place? Well, some growers have already started to embrace this latest technology. Mainly, it's not very much used in sugarcane. It's used in other cropping system. The variable rate technology, I mean that the herbicide rate automatically adjusts to speed. It had a drawback, that technology, as when the travel speed was high, it resulted in higher spray pressure, and when the travel speed was low, it resulted in low spray pressure. And this, when you affect the spray pressure, you also affect the spray pattern of the nozzle, and you affect the spray quality of the nozzle, which in terms of droplet size. So a new technology has been bolted onto the variable rate technology. It's called the pulse width modulation technology. I've got something in front. I can't see. Pulse width modulation technology, which actually use solenoids that rapidly open and close instead of getting the pressure up and down to control the spray rate at individual nozzle. So this pulse width modulation technology, all the pressure constant. Direct injection is another technology that most growers will be more familiar to. So injecting the herbicide straight from the drum, mainly we're talking about liquid herbicide, into the spray system, so it doesn't need to be premixed into the tank. It reduced leftover, rinsing. It's quite practical technology. In terms of nozzle, there's been a couple of nozzles of interest that haven't been used to my knowledge in sugar yet. 3D nozzle and ultra low drift max nozzle. So they're both aiming at reducing drift, but the 3D nozzle in particular has been designed to be efficient on vertical targets and salt cloths. So we could actually try this technology to spray grasses and nut grass, or to use for pre-emergent herbicide applied on bare soil or on trash blanket. Something to watch out. Guidance monitors with weed maps are the future, especially for zonal spraying. Spray some part of the field that have weeds, or even spray different type of herbicide on different part of the field that have different weeds. So that's the future at some point in time. This guidance monitor can have additional features, like where a section of the boom can be turned on and off when the row ends up on an angle, so you don't spray the headland. Can include variable rate as well in this type of technology. And in terms of automated spot spraying sensors, there's been some green from brown sensors, so they detect weeds on a brown background. They've been developed for years now. It's Weedseeker, the Weedit technology. They are great tools to use in fallow. In crops, it's a bit more difficult, as they spray on everything that is green, including the crop, which is why the research currently focuses on developing green from green sensor, which is going to try to discriminate the weeds from the cane. USQ has been working on a project using conventional discrimination methods, such as linear, I forgot the word, but some technology to use conventional method to discriminate using texture, color, line shapes, this sort of thing, while other companies like Autoweed, Bilberry, Blue River, and John Deere are using deep learning technology to try and teach the computer what a weed look like and what a crop look like by capturing a lot of images, and telling the computer that's a weed and that's a crop. There's currently a project running funded by GBIF with JCU and Autoweed to develop these deep learning green from green sensors and they're going to work from Townsville and the Burdekin. So now moving on to one of the drawbacks of chemical management is herbicide resistance and weeds becoming resistant to herbicide. The resistant weeds are actually naturally occurring. And it's a matter of putting enough pressure on the weed population by applying systematically the same chemical group or subgroup long enough to select the resistant type. Herbicides with similar mode of action are put into groups, group A, B, C, D, etc. And what is the mode of action? Herbicide kill weeds through various mechanisms at a cellular level, and every mode of action uses a different mechanism. So nowadays in the world, there's about more than 250 resistant grass and broadleaf weed species in more than 70 countries. And these resistance concern 11 distinct herbicide mode of action groups. And in some cases, weed species are resistant to more than one mode of action to make things more complicated. What happened in sugarcane in Australia? Not much just yet. In southern Queensland, there's been 3 weed species, cudweed, blackberry nightshade, and crossfoot, that have been found resistant to paraquat in 2015. To my knowledge, it hasn't spread any further than that. However, there's many other weeds that are present in the sugarcane system that have developed resistance to several herbicide groups in other Australian cropping systems, and we should monitor those closely. All these weeds in the green boxes are those weed species present in the sugar industry that have become resistant to herbicide mode of action in other cropping systems in Australia. So we have to be mindful for that. And in the orange box, it's the weed species that are present in the Australian sugar industry that have become resistant to some herbicide mode of action in sugarcane, but overseas. So we had some cases of Armless barnyard grass resistant to group C in Ireland, some case of wandering Jew resistance to group I in the US, and purple top chloris resistant to group C in the US. So we have to be mindful of this. It's at our doorstep. Herbicide resistance can be used to our advantage by making the crop resistant to the herbicide. And that's what herbicide-resistant crops are generated using transgene technology or mutation breeding. It's been widely adopted in other cropping systems, like in corn, cotton, and soybean. The only problem with this technology, it's very simplistic for the grower to use. And that has led to over-relying on the herbicide that the plant is resistant to. And this has accelerated the selection of herbicide-resistant weed species. So now the solution has become the problem. So one of the solutions has been to use the technique of trait stacking to make the crop resistant to several modes of action at the same time. In terms of sugarcane, what's happening? In Brazil, the CTN-Bio has developed their first GM sugarcane resistant to sugarcane borer in 2017, and they're currently working on releasing herbicide-tolerant cane in the coming years. So see what happened there. In Australia, there's been an SI joint venture in the past years with DuPont, and they managed to successfully introduce glyphosate-resistant technology into Q varieties, 208 and 240. The technology wasn't taken through to commercialization because it was quite complex. The alliance was terminated in 2019, and we do not have any herbicide tolerance variety in Australia currently at this stage. In South Africa, SASRI is developing traits through genetic engineering and mutagenic breeding, and they're targeting at herbicide tolerance, but also enhanced nitrogen use efficiency and drought tolerance. So that's what's in the space of herbicide tolerance sugarcane in the world. Chemical management can have off-target impacts. One of the off-target impacts is the drift. This drift problem is mainly an issue with the group I herbicide, like the hormone type herbicide, like 2,4-D, dicamba, and with like glyphosate. On the label, they precise exactly what type of recommendations are to be followed to reduce the drift issue. They mainly rotate about using appropriate nozzle that produce a very large droplet size. Boom height need to be minimized, often to less than 0.5 meter from the surface or the target. The inversion condition, surface inversion conditions need to be avoided. So these conditions mean that the herbicide can drift for many kilometers. They happen when there's nearly zero wind, often in the morning or in the evening, and they can be identified when there's fog or smoke hanging in the air. They need to be avoided at all costs, otherwise the drift can be moved away kilometers from the place it's been sprayed and hit a sensitive crop or sensitive environmental species. It's also, to avoid this surface inversion condition, it's recommended to spray when the wind is light, between 3 to 15 kilometers. Every label would have a specific condition to use to reduce drift. That's as a general rule. Target impact, the one that in the sugar industry we hearing the most of are runoff, chemical of target impact. As you would all know, the herbicide have been impacting on the health of the Great Barrier Reef Lagoon since 2009, where exceedances have been recorded. Restrictions on labels have been implemented, especially on the Diron label. However, exceedances nowadays are still recorded, especially with Diron, metolachlor, CPA, and atrazine. Chemical alternatives are often better, however, they still pose some environmental risk. So it's actually quite complicated, quite a complicated equation to be able to apply chemicals without harming the water course. What can we do? Timing to reduce the runoff risk. So how do we do that? Well, avoid that runoff event as much as possible, and ideally avoid any runoff event before 21 days after spraying is the golden rule. As herbicide concentration in runoff declines significantly over time, and they dissipate between day 1 and day 21 and keep dissipating, of course, but the further away from the spray application the runoff event is, the better. Incorporating herbicides by non-runoff inducing and irrigation or rainfall, like I said before, to facilitate binding into the soil is very, very efficient. And herbicide losses in runoff approximately half with every 50 millimeter of incorporating irrigation or rainfall. So very important to get your product incorporated before a runoff event. Zonal application can be a very good tool because losses are actually proportional to the amount applied. So the more, if you apply 2 kilo, if you apply 4 kilo, it's always better to apply 2 kilo. You get a chance to lose only half of when you compare when you apply 4 kilo. Using products that have low application rate is also working really well, like imazapyk and isoxaphutol. They are active at very low rate, which means only very low amount are lost as well. So these are one of the most recommended alternative herbicides. There would be a pesticide decision support tool developed by DES and UQ to be released soon that would assist growers and consultants in their pesticide choices. Other way to reduce runoff, I've been working on a project to determine if soil binding adjuvant would work to reduce runoff. So far, I have been only able to find benefit in tilled plant kind. Every time this product are applied in ratoon, compacted ratoon, either on bare soil or on trash blanket, they did not help in reducing losses of herbicide via runoff. They did in tilled plant kind. However, tilled plant kind naturally offers more binding sites and reduce herbicide loss via runoff. So it's not really good to have soil binding adjuvant that work in the condition that is actually the least problematic. The impact of trash blanket, does it increase or reduce herbicide loss via runoff? Well, it's actually quite unclear. There's some very contradictory papers out there. So we're not really sure what it does. It seems like it helps binding a bit the herbicides when the trash is a bit more decomposed than compared to when the trash is really fresh, but it hasn't been proven properly. So it's not really clear that space what the role of trash blanket. And as I said before, the soil conditioner, organic amendment meal byproducts. As they are really rich in organic matter, they bind tightly the herbicides. It does reduce their efficacy, but on other hand, it also reduces their loss. In the lab, it's been confirmed. Haven't been able to confirm it in small-scale field trial, but I believe it would work if they are tested in large-scale field trial. And I'd say it depends on the absorption capacity, and it depends on individual herbicides. So far, what has been found is Diron was really well retained by meal mud, while products like hexazinone and Imazapic were less retained by meal mud. Other off-target impact, very briefly, because there's not been much work done onto it. Leaching, chemical can leach, especially those that have low KOC and are highly soluble. It also depends on the soil type, same as a runoff, and same as, there's been a lack of monitoring and study in sugarcane in that space, so we can't really comment. But the logic would say that if you use herbicide with good binding property, it would reduce leaching. If you reduce the rate in light soil, it reduces leaching. So leaching means contaminating groundwater with herbicides and loss of chemical for efficacy. Plant back. So that's another off-target impact of chemicals. So when you apply chemical and it carries over due to its high persistence to the next crop, it can have an impact on the growth of the succeeding crop. It's been more covered in the last webinar, that part, so I'm not going to go over it again. So that was me for the chemical management option. Now, very briefly, I'm going to go into non-chemical management option. It's not much used in sugarcane at this stage, apart from the mechanical cultivation, which is still widely used in some regions, like in Far North Queensland, in plantain, from planting to out of end stage. It's also used to heal up. During all this mechanical cultivation, the weeds are being disturbed, and so basically they are cleaned from the ground. The problem with cultivation is a high risk of erosion and a reduction of soil organic carbon. Conditions for cultivation are critical. If it's too wet, you just transplant the weeds from one spot to the next. If it's too dry, it's good for the weeds, but you lose too much soil moisture for the crop. There are some automated mechanical weed control options using cameras that are quite complex out there. They have been developed in other countries, other crops. They are, at this stage, they are only economical in very high value crops. So they might come one day in sugarcane, but not just yet. Another form of physical, physical weed management is using heat through flame, for example. So flame, you can just crack the match and burn the trash residue with a hot burn, and you reduce your weed seed bank. But there's been some flaming devices that have been developed over the years. Started a long time ago in 1852 in the US. A sugarcane farmer, he invented a propane fuel flame weeding system. The advantage of flaming, it's quite low cost. It works better on small weeds. The main issue we've got for sugarcane to implement such a technique is the fact that we've got trash blankets. So if we try and do localized burning, the whole field will just catch on fire. It's very practical. Steam is another method. You can see a picture on the right of a handheld steamer. It's actually more effective than flaming. It can also kill the seeds in the ground, just on the surface, obviously. It's a bit more expensive than flaming. Again, more adapted to high-value crop because of that. There's an Australian company called Wheat Techniques that has developed saturated steam generator. Because it's very expensive to run, it's very expensive to buy, it's more adapted to high-value crop. Another physical control using heat is electricity. Weeds can be killed with 20 kilovolts by either spark discharge or electrical contact. A German company called Zasso Electroherb has been in that space for a while. Again, as technology mainly used for high-value crop. We have the same problem in sugarcane, is a risk of littering the trash blanket, and there's also a fair bit of safety as for the user, and a high cost. Microwave is another technology that actually is being mainly worked in Australia by Graham Brody from University of Melbourne. So basically the idea is to project microwave energy onto the plant and the soil to kill weeds and seeds. The energy density required depends on the weed species. There's currently a GBI innovation project funded in that space with a catchment solution. So to see how it could work in cane. So we are waiting to hear from them. Another non-chemical management option is biological control. So using natural living organism, often exotic, can be used to control weeds and limit weed infestation. It's quite complex to get to find and make sure this exotic living organism do not target any any non-target species and does not become a pest itself. Once it's worked, it's a cheap and long-lasting solution with less environmental impact. The problem is it targets a specific weed species. So it's basically mainly used for environmental weed control. For example, Biosecurity Queensland currently has 11 biocontrol research projects running to manage specific environmental invasive weeds. It's a technique that is rarely contemplated in the agriculture industry because we deal with not only one weed species, but a range of weed species, and we're using often additional chemicals to control the other that would harm natural living organisms that we want to use to control specific weeds. So it's a bit complicated for sugarcane or any agricultural crop. Biological control can be done using bio-based herbicides. There's a lot of research worldwide that have isolated phytotoxins, natural phytotoxin from many sources. Some have been patented for herbicide use. There's very little amount of bioherbicide commercialized. Just a range of product out there. The corn gluten meal can be used as a pre-emergent, but is used at very high rate and becomes very expensive. It's more organic farming system. Acetic acid, fatty acids, essential oils, all are contact herbicides, non-selective, quite expensive. Again, more adapted to organic system. Microbial product like the Bialaphos tripeptide is a product that is commercialized in East Asia. Once it's a pro-herbicide and it's metabolized in the plant into its herbicide form that looks very much like glufosinate. So it works. It's just not very much. It's not used in Australia. Brassicacea seed meal is another way, a bit like corn gluten meal. You use a right, so it becomes quite expensive. And again, it contains glucosinolate, which becomes herbicidal upon enzymatic hydrolysis. They're all products that are used in more like organic systems. So now we're going to look quickly into the cultural methods. So using the advantage inherent to the sugarcane farming system to control weeds. Well, we have one very good ally, it's a trash blanket. So trash blanket is a physical barrier, which got also allelopathic property. It's very good on grasses and small broadleaves, annual. It's not less efficient on perennial weeds and vines. We haven't really evaluated the quality and the quantity of the residue produced by Australian sugarcane variety, something that could be done. Shading is something that we have to use to our advantage because sugarcane is a tall crop, and creating intense shading, which limit the density and the biodiversity of the population and weed population underneath. So what could be done to increase that? We could select more light competitive cultivar. We could manipulate crop row spacing, crop row orientation, perpendicular to the path of light. We could also mix cultivar, for example, one row, one variety, the other row, another variety, with different growth rate to maximize light interference and compete with the weeds for the light. Cover crop, finally, is another tool that can be used to beat the weeds. Cover crop reduce soil temperature and light, which has an impact on weed seed germination and growth. Same for the cover crop residues. They can favor losses from the weed seed bank because they make them germinate or they lose their vigor or decay. The cover crop can influence weed seed predation. Cover crop often enhance soil productivity, which means the following crop will better compete with the weeds. Cover crop residue can be burned, which can result if a hot burn is achieved in weed seed death. If the hot burn is not achieved, it can induce seed germination, which can then be controlled before planting the crop. When using cover crop, the key is to control weeds before they set seeds, to not contribute to more seed in the seed bank. How can cover crop be tailored to be more efficient to control weeds? Mixing cover crop species to increase soil coverage over time can be used. So, for example, mixing a range of millet that germinate very quickly, followed by at the same time, and then planting at the same time millet, cowpea, soybean, lab, they all germinate at different rates, so they cover the soil at different time and ensure a proper soil coverage for a longer period of time, so it doesn't let weeds any opportunity to germinate without being outcompeted by some for shade by the fallow crop. Increasing seed rates can work really well, less room for weeds in between. Seeding methods can assist also. If you plant soybean wide row, narrowing the row would help to maximize light interception and more competition for the weeds. Intercrop is one of the last option. So what intercrop means is planting or growing more than one crop at the same time on the same piece of land. When you do that, well, you achieve more shading, you compete more with the weeds. The drawbacks is the intercrop compete with the weed, but can also compete with the crop and often compete with cane. In the literature, I found that better economics were only found when intercrop is harvested as a cash crop. Otherwise, there's too much competition between the intercrop and the cane. Interestingly, in South Australia, they've been using intercropping species, a non-invasive tuft grass called Milinus minutiflora that they planted in the interrow in sugarcane to compete with couch. And it did a great job at it. And this non-invasive tuft grass is then very easy to control. So intercrop can be used for that matter, just to control weeds in sugarcane. And the last method, non-chemical management method I want to mention is harvest weed seed destruction. It's used in grain crops. In grain crop, they use this. They use a different range of technique. One of them is a Harrington seed destructor, which is a machine directly integrated into the shaft stream of a combine harvester, which everything that is ejected through the shaft get grind into nothing, which means all the weed seed that gets through that shaft get destroyed up to 93 to 99%. So it's very effective at reducing all the weed seeds that are extracted through the shaft. In cane, we don't know. We don't have the knowledge of the amount and the type of weed seed ejected along with the trash by the extraction fans on the harvester. So Maybe this sort of technique would help stop weed seed dispersal. Maybe not, maybe we don't have any seed. I don't know, we haven't really studied it. So that's something to maybe research at some point in time. And that's it for me. So to conclude, first webinar, we review the main weed problem in cane. We talked about the importance of the weed ecology and the magnitude of competition and economic loss when doing weed management. And I presented the different aspects of integrated weed management, mainly chemical, but also biological, cultural, and mechanical. And along the stream, we identified a few gaps and opportunity for sugarcane industry to achieve better weed management. And that's me.
Thanks, Emily. Now, just before we go to questions, Alison, could you open up the poll, please? So we've got a very short poll here, and on the top of your screen, on the right-hand side of the raise hand icon, you'll see a little icon there with an F on it. If you could click on that, and you'll see the poll there. The poll's there now. So the poll question is, thinking 10 years ahead, what do you consider to be the most desirable technology or practice related to weed management in sugarcane? So there's 6 options there. Continued reliance on herbicides, use of weed detection sensor systems, microwave, flame, electrical or similar, autonomous robotic weeders, varieties that have natural tolerance through either conventional or genetic engineering, cultural methods such as self-thrashing varieties, intercropping, etc. So I think from memory you can have just list your 3 top opinions there rather than ticking all 6. So if we could just ask you to list up to three of those that you think are the future in weed management in sugarcane. So we'll give you 30 seconds or so to do that. Is that working for everyone? And then there's a submit button on the poll there once you've clicked your 3 answers. So there's 16 votes in so far, so there's a few more still coming in. So the most popular choice at the moment is use of weed detection sensor systems that allow weed detection and mapping systems, weed sensors, to auto spot spray. We'll see whether that changes. "19 votes in. The second most popular choice was autonomous robotic weeders. Followed by cultural methods. So it looks like we're pretty much done on the poll there with 19 votes in. So I think we'll 20. Okay, one last one in there. So I think we'll close that now. So the other thing we'd like you to do is we would also like to know if there's a specific subject that you would like for a future weed management webinar. And if there is, just use the conversation icon to jot a note down in the conversation there, listing the topic that you might like a future presentation to be on. If someone else puts a topic in there that you also like, use the like function to let us know that there's more than one person interested in that particular topic. So okay, so people can continue with that, making some notes in the conversation mode there whilst we take any questions from Emily's presentation today. So any questions, either put them in the conversation or use the raise the hand function there.
Phil, Bob has his hand raised.
Yeah, I can't find that. All right, so Bob, if you got a question, just unmute yourself and go for it.
Okay, thank you. Thanks, Emily, it was very interesting. A question about the use of lime. You didn't mention that, which might interfere with the use of some of the residuals. Could you make a comment on that, please?
Lime, is that what you said, lime?
Lime.
Yeah.
Yes,
No,
yes, I said lime, like affecting the pH. Could that have some influence?
Most herbicides are not too sensitive to pH, but we don't want to go to extreme pH either. So it's something to take into account. Every product would mention what pH would do to it. Top of my head, I don't know it. I don't know the answer, but it would be a matter of checking your herbicide label of the herbicide you intend to put before using lime, and it would indicate what to do. So there would be some product more or less susceptible to it. In general, it's not a big problem, but it's better to check regardless.
Yeah, okay, just following through that. So you'd say if one had a late or an older ratoon, which really was perhaps getting low in its calcium level,
Yeah.
You wouldn't hesitate to lime it if you still then had to go through and use a pre-emergent balance or other bits and pieces, Diuron, other bits and pieces for pre-emergent. You wouldn't say that wouldn't be a problem?
Well, we have to, every herbicide need to be checked. Depending on the herbicide you need to use, check the label would indicate if it would interfere or not.
Okay, thank you.
Juliet's posted a question there. When will the weed management manual be updated? We're about 99% of the way through the update. So we'd expect that hopefully, well, Christmas is coming up, so maybe very early in the new year, I'd say, Juliet.
Thank you.
Okay, I can't see any other questions in the conversation or hands raised, so that appears to be it. So last chance for any questions. Going, gone. All right, no, thank you. Thank you everyone for participating, and Well, here's a late question just popped in before we close down. Where's that? Question posed by Jordan. What's your next research proposal in the pipeline?
There's no research proposal in the pipeline because there's not much pipeline at this stage. But potentially we may work on a bit more on imidacloprid alternative. So it's not herbicide, it's more insecticide, and impact on the add-on runoff. In terms of herbicide, I don't have anything in the pipeline that shows any promise to get funded at this stage.
The recent call for expressions of interest by the SRA funding unit did not include any herbicide proposals.
Yeah, so there's no pipeline at this stage.
Yeah.
So I can't answer the question. I need the pipeline before.
Alrighty, so that looks about it. So again, thank you for everyone for participating, and thank you to Emily for the presentation. And we'll look forward to what the next webinar will be. Okay, thank you, everybody.
Thank you.
Thank you. Goodbye.
Yep, thanks.